Section 3.7, evaluating determinants and applying Cramer's rule. Now this only works when you have a square matrix of n by n size, and what you find is a determinant, and it's denoted by a DETA or absolute value A. I'd avoid using this one altogether because the absolute value bars may be confusing. So determinant A, DETA. To find the determinant of a 2 by 2, you go diagonally from the upper left to lower right, multiply that, and then subtract from it, go from lower left to upper right. That will give you the determinant of a 2 by 2. For 3 by 3, it's much more complicated. First thing you need to do is take the first two columns and repeat them outside the matrix. Then you take the products of these three numbers going diagonally across, and then get the sum of those products, and then subtract from them, going from lower left to upper right 3 times. That's how you find the determinant. Let's try an example here below. For the first one, 2 by 2, we just go from 5 to 1. 5 times 1 is 5. Subtract the 3 minus 4, which is 12. Negative 7 is the determinant. Pretty easy for the 2 by 2. 3 by 3, you've got to rewrite these first two columns. 2, 4, 3, negative 1, 1, and negative 4. And we start off by going diagonally down, diagonal, diagonal. It's kind of nice if you can do these on graph paper and put a number in each cell, because the spacing is even. You can get these diagonals to line up nicer. Otherwise, you might lose your numbers. So I'm going to multiply across here. 2 times 1 times negative 2 is negative 4. Negative 1 times 0 times 3, all that is 0. I love those. And 3 times 4 is 12. Negative 12 times negative 4 is positive 48. Okay, so I did those. I subtract these 3 diagonal products. So 3 times 1 times 3 is negative 9. 4 times 0 times negative 2 is just 0. And negative 2 times 4 times negative 1 is positive 8. And to simplify now, this is going to be 44 minus a negative 1, or just add the 1 to be 45. So there's your determinant calculation. You can use this to find the area of a triangle. And to do that, you take the 3 points, the x and y values, and put a 1 with them, which is a placeholder, because the values of 1 here don't really change what's happening with the products. And I'll show you how that works on the next page. Again, you have a 3 by 3 matrix. This is the first point, second point, third point. The order does not matter. Put them in any order you like. Put a 1 for a space holder out here to give us a 3 by 3 matrix. And also for this area, you have a plus and minus, because you might get a negative depending on the order of the points. And take 1/2 times whatever you get from the determinant. That is the area. We won't do this example here. We'll go to, if you go into the skills practice, number 22. Again, there's 3 points. Find the area. So I'll build my matrix, and again, it's going to be plus or minus 1/2 of whatever I get. So 1, 5, then a space holder of 1. 4, 6, space holder 1. 7, 3, space holder of 1. Well, don't forget, now you do your regular determinant of 3 by 3. Repeat these 2 columns, 1, 4, 7, 5, 6, and 3. And then I go diagonally down those 3, those 3, those 3. So try not to forget this 1/2 plus or minus later. 1 times 6 is 1, times 1 is 6, sorry. 5 times 1 times 7 is 35. 1 times 4 times 3 is 12. Subtract, going up this way, this way, this way. 7 times 6 is 42. 3 times 1 is just a plain old 3. 1, 4, 5 is 20. Again, it's plus or minus 1/2. 41 and 53 minus 62, 65. So 65 minus 53 looks like a 12. Again, plus and minus 1/2. Plus and minus 1/2. Half of 12 is 6. It's already positive. There's your answer, 6 square units. That's the area. Good luck.